Okay, so dear students, next we'll move on to the next topic. Okay, in the continuation, so we have seen what is RAM chip implementation. Okay, with various examples. So related questions you can solve from the workbook. So I told you already, right? So next we'll move on to the next topic in the continuation, that is loading, linking and address binding. So this is much as actually theoretical topic. So what is the meaning of all this? We'll understand one by one. So first keep the heading loading first. Note down. So keep the heading loading. Okay. So first listen to me. What is the meaning of loading first? Okay. Later you can write down the definition. But listen to that. Now, initially if you want to execute any program, initially your program will reside in the secondary memory, and if you want to execute your program, then that will be brought from your secondary memory to what? Main memory. Okay, so all of you know that already. So whenever you are trying to execute, so that will be brought from secondary memory to main memory. So remember, the bringing the program from secondary memory to main memory. Bringing the program from secondary memory to main memory is called as what? Loading. Is called as loading. Okay. Note down the definition. Loading the program from secondary memory to main memory. From secondary memory to main memory is called as bringing the program from secondary memory to main memory is called as loading. Okay, so that is the meaning of loading here. Next, note down, the next is linking. Note down, so keep the heading linking first. Keep the heading linking. Note down the definition. Establishing the linking between all the modules or all the functions of the program. Establishing a linking between all the modules or all the functions of the program in order to continue the program execution. In order to continue the program execution is called as linking. Is called as linking. Okay, so please copy this in the continuation में इसको लिखो. Okay, I will explain what is the meaning of this. Copy this. Copy this. Okay, you are having main integer x equal to add. You are having this, and in the add function you are having this. So this is all linking. So what is the meaning of this? Okay, I will explain that. Copy किए इसको. Copy नहीं कर तो pass करो. Pass करके copy करो. Okay. Now what is the definition you have written? Now tell me. Linking means what? Establishing the linking. Repeat कर रहा हूँ फिर से. Establishing the linking between all the modules or all the functions of the program in order to continue program execution is called as what? Linking. Okay, so it means what? Let's say you are having the program here. Let's try to understand here. You are having main integer x. Just listen here. Main, you are having integer x. So x equal to add. You are having this function here. Okay, so x equal to add function है. Okay, यहाँ पे इसका मतलब क्या है? Whatever the value returned by this add function, that will be assigned to what? Variable x. Now remember, whenever you are executing this line of your program, so from here you directly jump to what? Add function. So from this line you directly jump to add function, and let's say you are reading some variables here, okay, whatever x, y, z, and performing some addition, and the return value total, okay, will be assigned to what? Variable x. So whatever this function is returning, so that value will be assigned to what? Variable x. Is that clear? So it means, okay, understand here. So whenever you are executing this, you directly jump from here to what? This add function. So how that is actually happening? That is all actually happening internally with the help of what? Linking. So that's all actually happening internally with the help of what? Linking. Is that clear for everyone? Right. So now understand here. So establishing the linking between all the modules or all the functions of the program in order to continue program execution is called as what? Linking. Now actually you can observe this. Let us say you are having around 10,000 lines of code. Let's say your program is having around 10,000 lines of code, and remember, whenever you execute this line, so from here you directly jump to add function. So from here you directly jump to add function, you are reading the variables, okay, x comma y, whatever you are having, and performing addition and returning the total here. So that will be assigned to variable x. So when you are having 10,000 lines of code, but still whenever you execute this, from here you jump to add function. How that is actually happening? That is actually happening with the help of what? Linking. Is that clear? Right. Now remember, next, loading and linking. Understand carefully. Loading and linking is further categorized into two types. Loading and linking is further categorized into two types. Okay, one is static. Okay, one is static and next is dynamic. Okay, one is static and next is dynamic. No doubt. Okay, no doubt. Next line, continuation. Loading and linking is further categorized into two types. Loading and linking is further categorized into two types. That is a static. One is a static and next is a dynamic. So one is static and next is a dynamic. Okay. So what is the meaning of static and dynamic? Okay. Let us try to understand first. So note down. First, keep the heading static first. So note down. First, keep the heading static first. Keep the heading static. Note down. First point, first point. Loading the entire program. First point लिखो. Static में first point लिख रहा है. Static में first point. Loading the entire program into memory. Loading the entire program into memory before start of program execution. Loading the entire program into memory before start of program execution is called as a static loading. Is called as a static loading. Okay, full stop. Now understand here. So what is the meaning of static loading here? Static means what? Loading the entire program into memory before start of program execution. Okay, it's called as what? Static loading. It means what? It means whether the program is required or not required, you are loading the entire program into memory before start of program execution. So that is called as what? Static loading. Now remember, if you are following the static loading, then what happens? Okay, remember, okay, if you follow the static loading, बताओ आप लोग, okay, whether it's required or not required, you are loading entire program into main memory. So before start of program execution only. So if this is the case, okay, whether it's required or not required, you are loading entire program. Okay. So now tell me, if that is the case, memory utilization will be efficient or inefficient? बताओ क्या होगा? Okay, inefficient होगा. Is that clear? Right. So now remember, actually in your colleges, when you write the program, sometimes okay, you declare the variables, okay, integer x, integer y ऐसे ही declare करते, okay, कभी use करते, कभी use नहीं करते, भगवान जाने. Is that clear? Right. So it means, okay, so that is the reason, whatever the variable, even a single variable you declared when you are writing a program, the memory will be allocated. So efficient programming skills are required. Okay, which will take less memory and space complexity. Is that clear? Right. Okay, but like sorry, memory, time complexity and space complexity. Is that clear? So understand carefully. So it means the same thing here. When you follow the static loading, okay, next point, क्या लिखना है? Memory utilization will be efficient or inefficient? Inefficient. Okay, note down. Second point लिखो. Memory utilization will be inefficient. Memory utilization will be inefficient. Okay, so that is the okay. So static loading. Next, now okay, tell me the next point. Okay, same static loading mein next point. Now okay, memory utilization to inefficient hoga, that is fine. If I follow static loading, सोच के बताओ. Okay, if I follow static loading, the program execution, coming to the program execution will be slower or faster? Program execution will be slower or faster? Program execution will be faster. Is that clear? Why? Because the entire program is in the main memory, right? So okay, there is no need to wait for anything. Okay, किसी के लिए wait करने की कोई जरूरत नहीं है. So entire program is in the main memory. So the program execution will be faster. Okay, note down. Next point. The program execution will be faster. The program execution will be faster. Okay, next. Note down. Next point. Ligo. If the static loading is used, accordingly, the static linking will be applied. If the static loading is used, accordingly static linking will be applied. Is that clear? So understand here. So same thing, if you are using the static loading, so obviously accordingly you need to okay use what? Static linking. Okay, so both are related. Okay, static loading use कर रहे हैं तो obviously static linking use करना पड़ेगा. Okay, so that is the okay static. So note down. Next is dynamic. So keep the heading dynamic next. So next keep the heading dynamic. Now what's the meaning of dynamic? Listen here. So dynamic means loading the program into memory on demand. Loading the program into memory on demand is called as what? Dynamic. So on demand का मतलब क्या होता है? On demand means whenever it is required. So whenever it is required, then only that particular part of the program will be loaded into memory. So that is called as what? Dynamic loading. Okay. So understand here, if you observe this program, okay, generally if you observe this program here, so okay, whenever you are executing this program, initially we are going to load only what? Main function. So initially we are going to load only main function. Okay, the answer is not just say initially you load only main function, and whenever you execute this line, okay, whenever you execute this line, okay, it requires what? Add function is required. If you want to execute this line, the add function is required. So initially add function will not be loaded into memory. So then what happens? The program execution will stop. The program execution will stop for some time period. The program execution will stop for some time period, and dynamically you are going to load this add function into memory. So dynamically you load this add function into main memory, and dynamically you establish the linking between these two things. Dynamically you establish the linking, and then the program execution will continue. So then the program execution will continue. Is that clear? So that is called as what? Dynamic. It means loading the program into memory on demand. On demand means whenever it is required. So when it is required, then only that particular part of the program will be brought into memory. So that is called as a dynamic loading. Note down the statement. Statement लिखो आप लोग. Loading the program into memory. Loading the program into memory on demand. Loading the program into memory on demand is called as a dynamic loading. Loading the program into memory on demand is called as a dynamic loading. Okay, right. Now tell me, okay, if I follow dynamic loading, okay, then tell me If I follow dynamic loading, the program memory utilization, tell me, memory utilization will be efficient or inefficient? If I follow dynamic loading, program is efficient or inefficient? Efficient, obviously, right? So whenever it is required, then only you load the program into memory. So obviously that is a efficient utilization of memory. Okay, no doubt. Next point, memory utilization will be efficient. Memory utilization will be efficient. Memory utilization will be efficient. Okay, full stop. And next, now understand here, coming to the program execution. बताओ सोच के आप लोग, if I follow dynamic, the program execution will be slower or faster? Program execution will be slower or faster? Program execution will be slower. Is that clear? Right. So program execution will be slower. Understand here. Okay, why? Because initially this will not be available, so program execution थोड़ी देर के लिए stop हो जाएगा. Dynamically this will be loaded and dynamically you establish linking, then the program execution will continue. So like this, so that is the reason the program execution will be slower. Okay, no doubt. Next point. Next point, लिखो, the program execution will be slower. Program execution will be slower. Okay, no doubt. Next point. Next point, लिखो, if the dynamic loading is used, accordingly dynamic linking will be applied. If the dynamic loading is used, accordingly dynamic linking will be applied. Okay. So, okay, understand here. So, if the dynamic loading is used, accordingly we need to implement a dynamic loading. So, dynamic loading use kare to dynamic linking hoga. Is that clear? So, same thing, obviously loading and linking both are interrelated. So, if you are using dynamic loading, then you need to use what? Obviously dynamic linking. So, that will be used accordingly. So, now understand here. So, that is about loading and linking. So, with the loading and linking, what is happening is we simply load the program into memory. Understand here. Okay, let us say, okay, you are having the memory here. Okay, just listen. So memory is divided into various blocks. Okay, or is generally called partitions. I will explain, don't worry. So okay, the memory is divided into various blocks. Let's say you are having some program here. Okay, the answers no. Okay, let's say you are having program P1. Okay, you are having some program. Program will contain what? Set of instructions. So whenever you say program will contain set of instructions. So remember, with the loading and linking, what happens is you simply load the program into main memory. So you simply load the program into some particular block of the memory here. Let's say you are loading, okay, into some block number 6. Now remember, once the loading is done, loading and linking is done, next step what will happen? Address binding. Okay, the answers know what to say. Okay, once the loading, linking, and next step what will happen? Okay, address binding. What is the meaning of address binding? The answers know what to say. Address binding means, पहले सुनो definition मैं देता हूँ, notes देता हूँ पहले सुनो अच्छे से. Address binding means association of program instructions, association of program instructions and data to the actual physical memory locations is called as a address binding. Association of program instructions and data to the actual physical memory locations is called as a address binding. इसका मतलब क्या होता है? What's the meaning of this? Listen here. The answers are अच्छे से. With the loading linking, you simply dump the program into some particular block. Okay, with after that address binding will happen. Address binding means establish association of program instructions and data to the actual physical memory locations. It means what? It means every instruction of the program. Every instruction of the program will be binded with the actual physical address. Every instruction of the program will be binded with the actual physical address. Okay, like for example, listen here. So I1, you are having instruction I1, it is binded with the address 10. So I2 binded with the address 20. So I3 binded with the address 30. So I4 binded with the address 40. So every instruction of the program will be binded with what? Actual physical address. Okay, every instruction of the program will be binded with the actual physical address. So that is called as what? Address binding. Is that clear for everyone? Right? So okay, the answers now मैं repeat कर रहा हूँ. Okay, address binding का definition फिर से बता रहा हूँ. Association of program instructions and data to the actual physical memory locations is called as a address binding. So it means every instruction of the program, okay, every instruction of the program will be binded with the actual physical address. Okay, like I1 binded with the address 10, I2 binded with the address 20, okay, that is 30, that is 40. So now once address binding is done, the next what happens, look at here, the program counter will be assigned, the program counter will be assigned with the address of the, okay, instruction I1, okay, look at here, that is 10. Address of the instruction I1, that is 10. Now remember, when you are executing the program, the CPU will simply identify, when you are executing the program, the CPU will simply identify what is the address available in the program counter. It will just go to the, okay, program counter address. What is the address available here? 10. So it will go to that particular location in the memory and it will fetch that instruction and continue the execution. So how it is going to fetch the instruction and how it will decode and how it will execute, okay, all that you will study in the CO, computer organization, instruction execution cycle. Okay, instruction fetch, decode, execute, you will study all that. Okay, right. So the answer is not just say. So okay, program counter will be assigned with what? Address of the instruction I1. So okay, when the CPU is executing, it will see what is the address available in the program counter. So once it is done, instruction I1 execution is completed. I1 execution is completed. Then what happens? Program counter will change to what? Program counter will change to address of the next instruction to be executed. So what is that here? 20. So it will change to 20 here. Then it will execute instruction I2. So then it will change to what? Okay, 30. Then it will change to what? 40. So like this, we are going to execute instruction by instruction. So okay, so main purpose of the address binding is, once address binding is completed, we will come to know which instruction is available in the which particular address. Which instruction is available in the which particular address. So that we will come to know. So once address binding is done. Is that clear for everyone? Right? No doubt. No doubt. First, keep the heading address binding. इसको बाद में copy करो. पहले सुनो इसको. Keep the heading address binding. First address binding heading लगाओ first. Then note down the definition. Definition लिखो. उसके बाद इसको copy करोगे. Right? Okay. Keep the heading address binding. Note down the definition. Keep the heading address binding. Note down. Association of program instructions, association of program instructions and data, association of program instructions and data to the actual physical memory locations, to the actual physical memory locations is called as address binding. To the actual physical memory location is called as address binding. Is that clear? Right. So that is address binding here. Okay, copy karo, copy this. Okay, just continuation में इसको copy करो. Copy this. Okay. So if you are not copied, then you can just simply pass करो, pass करके copy करो, right? So I am moving ahead. Okay. So copy नहीं करे तो pass करके copy करो. Okay. No doubt. Next continuation में लिखो. Address binding is categorized into 3 types. Okay. Understand carefully. Address binding is okay, categorized into 3 types. No doubt. Continuation. लिखो. Address binding is categorized into 3 types. One is compile time address binding, and next is load time address binding, and next is execution time address binding, or okay, sometimes it is also called as dynamic address binding. Okay, execution time address binding or dynamic address binding. Okay. Copy karo. Copy this. Address binding categorized into 3 types: compile time address binding, load time, and execution time address binding. Okay. So understand here. Okay. One by one. First, keep the heading compile time address binding. First, keep the heading compile time address binding. Okay. Note down the statement. If the compiler is responsible of, इसमें compile time address binding लिख रहा है. If the compiler is responsible of performing address binding, if the compiler is responsible of performing address binding, then it is called as compile time address binding. If the compiler is responsible of performing address binding, then that is called as a compile time address binding. No doubt. Next point, this type of address binding will be done. This type of address binding will be done before loading the program. This type of address binding will be done before loading the program into memory. This type of address binding will be done before loading the program into memory. No doubt. Next point. The compiler requires to interact. The compiler requires to interact with the operating system memory manager. The compiler requires to interact with the operating system memory manager to perform compile time address binding. To perform compile time address binding. Okay, understand here. So that's it. Okay, utna hi hai, only 3 points. 3 points in this. Now understand here. So compile time address binding. So who is responsible of performing this? Okay, compiler. So compiler is responsible of this. So what is the first point you have written? If the compiler is responsible of performing address binding, then that is called as what? Compile time address binding. Now second point is important. What is the second point here? This type of address binding will be done before loading the program into memory. Before loading the program into memory only we are going to perform address binding. Is that clear? मतलब program main memory में आने से पहले ही address binding हो जाएगा. So how that is actually possible? ये कैसे possible है? मेमोरी में से आने से पहले address binding कैसे हो सकता है? राइट, इसलिए थर्ड पॉइंट दिया. थर्ड पॉइंट पढ़ो. थर्ड पॉइंट क्या दिया? थर्ड पॉइंट क्या दिया? पढ़ो. Okay, the compiler requires to interact with the operating system memory manager to perform compile time address binding. It means what? Okay, compiler will interact with the operating system memory manager, like where the program will be loaded into memory. Okay, it will interact with the operating system memory manager where the program will be loaded into memory, and accordingly it will perform the address binding. Accordingly it will perform the address binding. Is that clear? Right. So compiler will interact with the operating system memory manager where the program will be loaded into memory, and it will come to know. Okay, it will interact with the operating system memory manager. So accordingly it will perform the address binding. Is that clear? So I am repeating. So this type of address binding will be done before loading the program into memory. Okay, who will do that? Compiler will do that. Okay, so that is the compile time address binding. And next is what? Load time address binding. No doubt. So keep the heading load time address binding. No doubt. Keep the heading load time address binding. So what is the meaning of load time address binding? No doubt. This type of address binding will be done after loading the program into memory. This type of address binding will be done after loading the program into memory. Okay, right. So understand here. So this will be done what? After loading the program into memory. Okay, load करने के बाद होगा. Who is going to perform this? No doubt. No doubt. Next point. Load time address binding will be done by operating system memory manager. load time address binding will be done by operating system memory manager. Okay, that is okay loader. ब्रेस इसमें लिखो loader. Okay, ऑपरेशन मेमोरी मैनेजर मतलब कौन करता है, वो लोडर करता है. इज दैट क्लियर? लोडर इज रेस्पॉन्सिबल ऑफ परफॉर्मिंग लोड टाइम एड्रेस बाइंडिंग. Load time address binding will be done by the operating system memory manager. So braces में लिखो loader. Okay, right. Only 2 points. Okay, understand here. So repeat कर रहा हूँ फिर से. Load time address binding. This will be done what? After loading the program into memory. Is that clear? So load time address binding will be done after loading the program into memory, and who will do that? Operating system memory manager. So that is what? Loader. Loader is responsible of this. And next, listen carefully. So these were just a theoretical idea. Compile time address binding, load time address binding, they are all just theoretical idea, but practically used is what? Execution time address binding. Practically used is execution time or dynamic address binding. So this is important. Okay, no doubt. Keep the heading next, execution time address binding or dynamic address binding. No doubt. Execution time address binding or dynamic address binding. No doubt. Okay, first point लिखो. The address binding will be postponed. No doubt. The address binding will be postponed even after loading the program. Address binding will be postponed even after loading the program into memory. Address binding will be postponed even after loading the program into memory. No doubt. Next, second point. The program will keep on changing. The program will keep on changing the locations in the memory. The program will keep on changing the locations in the memory till the time of program execution. The program will keep on changing the locations in the memory till the time of program execution. Next, note down next point. Third point. This type of address binding will be done by the processor. This type of address binding will be done by the processor at the time of program execution. So this type of address binding will be done by the processor at the time of program execution. Okay, full stop. Now understand here. Okay, this is the execution time address binding. So this is important. Just listen carefully. So what is the meaning of this? Okay, first point क्या लिखे पढ़ो अच्छे से. First point, the address binding will be postponed. Address binding will be postponed even after loading the program into memory. इसका मतलब क्या है? लोड करने के बाद भी अपन एड्रेस बाइंडिंग नहीं करेंगे. इसलिए ओके, वाई ऐसा क्यों करोगे? ओके, पोस्टपोन क्यों कर रहे हैं, क्यों नहीं कर रहे एड्रेस बाइंडिंग? सेकंड पॉइंट क्या लिखे? द प्रोग्राम विल कीप ऑन चेंजिंग द लोकेशंस इन द मेमोरी टिल द टाइम ऑफ प्रोग्राम एग्जीक्यूशन. मतलब प्रोग्राम चेंज करते रहेगा. ओके, उसका लोकेशन को चेंज करता रहेगा. इसलिए कैसे? फॉर एग्जांपल लिसन हियर. Initially you are loading the program into, let's say, block number 6. Let's say for example you are doing the address binding here. You have done the address binding. Every instruction will be binded with the actual physical address. So if you are binding, you perform the address binding here, and after that it is changing into some other location. Let's say it is moving from block number 6 to, let's say, block number 1. Okay, so then what happens? Whatever the address binding you have done here, that will be waste only. Right? And next, let's say, now it is in the block number 1. Let's say again you are doing address binding. Let's suppose you are doing address binding. Then after that, sometime, it is changing from block number 1 to, let's say, block number 4. Then what happens? Whatever the address binding you have done, that will be what? Waste only. Is that clear? So that is the reason the address binding will be postponed even after loading the program into memory. Why? Because the program will keep on changing the locations in the memory till the time of program execution. इसका मतलब कभी यहाँ पे, उसके बाद थोड़ी देर के बाद let's say A block में आया, कभी उसके बाद ये block में आया. Is that clear? So it is keep on changing the locations in the memory till the time of program execution. Now, why it will change like that? Why it will change like that? Remember that all depends on memory management technique the operating system is following. That all depends on memory management technique the operating system is following. Example, like for example, okay, OS thought that initially, okay, this is the right place for the processor. Maybe after that, okay, OS thought, okay, this is the right place for the processor. Maybe after that, okay, OS thought this is the right place for the processor. Okay, that all depends on, okay, the decision of the operating system. That all depends on the memory management technique the operating system is following. So that is the reason it will keep on changing the locations, okay, so in the memory till the time of program execution. So then when it is going to be, okay, done, address binding kab hoga yahan pe, last point kya likhe, this type of address binding will be done by the processor. Okay, this type of the address binding will be done by processor at the time of program execution. It means what? Now let us say now you are decided to execute the process P1. It means what? That is the final place for the processor. When you decided to execute that process, it means what? That is the final place for the processor. Okay, it means okay, it is not going to change any more location. That is the final place. So then, okay, you perform the address binding. Then the address binding will be performed here. Okay, every instruction will be, okay, binded with the actual physical address. Okay, who is going to do that? Processor. CPU will do that. Processor will do that. Is that clear? So processor will perform the address binding. Is that clear? So at the time of program execution, मतलब जब आप execute करने वाला है, you are about to execute the program, it means that is the final place for the processor. So then the CPU will perform address binding and then it will continue the execution. Is that clear? So that is the, okay, execution time, or is a dynamic address binding. Okay. Now remember, whatever we studied till now, practically used, whatever we studied till now, okay, among all that, practically used is everything is a dynamic only. Like for example, majority of the operating systems will follow, okay, practically follows dynamic loading, dynamic linking and dynamic address binding. Is that clear? So everything is what practically used is only dynamic only. Okay, note down this point. Continuation, keep it as a note. Okay, keep it as note. Note down this statement. Majority of the operating systems, note down, keep it as note, note down that point. Majority of the operating systems practically implement dynamic loading, comma dynamic linking, dynamic loading, comma dynamic linking and dynamic address binding. Dynamic address binding. Okay, so you can take example. Example is what? Okay, all our popular operating system, like you can take example Windows, Unix, Linux. In all our popular operating systems, we use dynamic only. Is that clear? Right. So example, you can take Windows, Unix, Linux. Right. So that is okay, understand here. So that is okay, loading, linking and address binding. So that is just okay, just a theoretical idea actually. So some theory questions are there, okay, in the workbook. You can solve them, okay, based on that. Okay, सारे क्वेश्चंस आपको ही सॉल्व करना है, पहले आपको सॉल्व करना है, क्लास सुनने के बाद सारे क्वेश्चंस आपको सॉल्व करना है, राइट. Okay, so that is the okay small theory topic, so not that much important. Next we'll move on to the important part of the memory management. So note down, so that is okay, memory management techniques. Memory management techniques. Okay, understand here. So next we'll move on to the next one, that is the memory management techniques. Okay, so listen carefully. Okay, just note down, copy karo pehle to. Memory management techniques are categorized into two types. Memory management techniques categorized into two types. One is contiguous and next one is non-contiguous. Okay, non-contiguous. First one is a contiguous, next is a non-contiguous. Okay, and in the contiguous memory management techniques, in the contiguous we'll study two things. Okay, copy karo. One is a fixed partition scheme. One is a fixed partition scheme and second one is variable partition scheme. Okay, so first one is the fixed partition scheme, and next one is the variable partition scheme. And next in the non-contiguous we'll study. So first we'll study paging. Okay, second one is so multi-level paging. So third one is inverted paging. So for the segmentation, and next segmented paging. So memory management techniques are categorized two types. Okay, one is a contiguous memory management techniques, and next one is a non-contiguous. Okay, please copy all this properly. So in the contiguous memory management techniques, we study two things: fixed partition scheme and variable partition scheme. And in the non-contiguous, we'll study paging, multi-level paging, inverted paging, segmentation, and segmented paging. Okay, right. So if you are not copied, then you can pause my video. Okay, pause करके अच्छे से copy कर लो, मैं हटा दे रहा हूँ. So first we'll start with the contiguous memory management techniques, and we'll finish up this, and then we'll move on to non-contiguous. Okay, so I'm removing this. You can pause my video. Okay, if you are still copying, you can pause my video and copy all this. Okay, so we'll study in detail. Okay, so with all the questions and all the problems and everything. Okay, right. So next, let's begin with what contiguous memory management techniques. So first, keep the heading contiguous memory management techniques. So contiguous memory management techniques. So the first one is what? Fixed partition scheme. Note down. So make the proper heading. Keep the heading contiguous memory management techniques. First one is a fixed partition scheme. So what is the meaning of a fixed partition scheme? Okay, listen here. So copy this diagram. So you are having memory like this. You are having various partitions in the memory. Copy करो अच्छे से. So let's say 50 KB, 100 KB, 150 KB, 300 KB, 200 KB, let's say 250 KB, 70 KB, 120 KB. Okay, so just copy this, and these are called as what? This is called as a partition, or sometimes it is called as a chunk, or it is also called as a block, or sometimes it is also called as a whole. So the different textbook follows the different name. Okay, so but the meaning of all that is same. Copy karo, please copy all this. I'll explain all that. Okay, I'll make the proper notes and all that. Don't worry. So make a proper copy first. ओके. So if you are not copied, you can pause. Same thing. Okay, बार बार बोलने की जरूरत नहीं है. Okay, copy नहीं करे तो pause करो. Right. Now understand here. So first one is a fixed partition scheme. What is the meaning of this? Okay, listen carefully. So in the fixed partition scheme, memory will be divided into fixed number of partitions. ओके सुनते सुनते कॉपी मत करो. अगर कॉपी करना है तो पॉज करो अच्छे से. ओके कॉपी करो. ओके उसके बाद कंटिन्यू करो वीडियो. समझ में आया सबको? राइट. ओके अंडरस्टैंड हियर. सो इन द फिक्स्ड पार्टीशन स्कीम द मेमोरी विल बी डिवाइडेड इनटू फिक्स्ड नंबर ऑफ पार्टीशंस. Now remember, okay, fixed number of partitions. When I say fixed here, what is fixed is number of partitions are fixed. So I am not talking anything about the size. Look at here. So don't look at the size here. I am not talking anything about the size. So size may be same or may not be same. What I am talking about number of partitions. Now tell me how many partitions are there? How many partitions are there here? कुछ लोग 7 बोल रहे हैं. 7 कौन बोला है? ओके मारूंगा पकड़ के. राइट ऊपर भी देखो यहाँ पे. राइट सो 0 to 7 टोटल how many partitions? 8 partitions. Is that clear? Right. So understand here. Okay. So 0 to 7 total 8 partitions are there. Is that clear? Right. So this 8 is fixed. What is fixed is 8 is fixed. Okay. So number of partitions are fixed. How many partitions are there? 8. 7 8. Okay, right. So understand it. So number of partitions are fixed. So in the fixed partition scheme, memory will be divided into fixed number of partitions. So fixed means number of partitions are fixed in the memory. Okay. So this called as what? Okay, partition or okay called as a block or say chunk or whole. Okay. So meaning of all that is the same only. Different textbook follow different okay name. That's it. Okay. Note down this point first. Make a note of the point. First point, in the fixed partition scheme, memory will be divided into fixed number of partitions. Memory will be divided into fixed number of partitions. Full stop. Note down next point. Fixed means number of partitions are fixed in the memory. Fixed means number of partitions are fixed in the memory. Okay. So understand here. Okay, fixed means number of partitions are fixed in the memory. Is that clear? So understand carefully. So what is fixed here? Number of partitions. कितने partitions है यहाँ पे? 8. So this 8 is fixed. Okay, fixed मतलब क्या है बताओ? 8 fixed है. Number of partitions fixed. Okay, next important point. Just listen here. In the fixed partition scheme, we follow the strategy. Like in every partition. Only one process will be accommodated. Okay, understand here. Okay, in every partition only one process will be accommodated. Is that clear? So in every partition we accommodate only one process. Okay, listen here. So the answer is what you say. Okay, so like this. Okay, this is a partition here, this is a partition here. So in every partition we will accommodate only what? One process. In every partition we accommodate only one process. Is that clear? So if that is the case, okay, the answer is what you say. In every partition we accommodate only one process, and moreover I am saying that okay number of partitions are fixed in the memory. So how many partitions are fixed here? 8 partitions are fixed. Okay, in my example, okay, 8 is fixed. So in every partition you can accommodate only one process means maximum how many processes you can bring into memory? Okay, 8 process only you can bring, right? In every partition you accommodate only one process. You are having only 8 partitions here. So it means okay maximum you can bring only 8 processes into memory. It means इसका मतलब क्या होता है बताओ? इसका मतलब it means degree of multi-programming. याद है degree of multi-programming क्या है? Definition क्या है? हाँ कुछ लोग सोच रहे हैं याद है राइट. फर्स्ट क्लास में बताया गजनी बन रहे. गजनी सब लोग भूल गए कुछ लोग तो राइट. हाँ कुछ लोग सोच रहे हैं सर फर्स्ट क्लास में बताया अभी तक कैसे याद होता है right. Okay, so degree of multi-programming, number of process present in the main memory at any point of time. number of process present in the main memory at any point of time is called as the degree of multi-programming, right? So here we are having 8 partitions, means maximum you can bring only 8 process. So it means okay, degree of multi-programming is restricted by number of partitions in the memory. Is that clear? So here you are having 8 partitions, so maximum you can bring only 8 process. So maximum degree of multi-programming will be what? 8 only. Is that clear? Right. Okay, note down the next point. Next point लिखो. In every partition only one process will be accommodated. In every partition only one process will be accommodated. Okay, full stop. So understand here. So in every partition accommodate only one process. Is that clear for everyone? Right? Okay, एक partition में एक ही process होगा. So okay, that is the important point you should remember in the fixed partition scheme. So if this is the case, what is the problem? In every partition accommodate only one process. Okay, इसके कारण क्या हो रहा है? Okay, note down. Next point. Degree of multi-programming. Next point लिखो. Degree of multi-programming is restricted by number of partitions in the memory. Degree of multi-programming is restricted by number of partitions in the memory. Okay. So degree of multi-programming is restricted by what? Number of partitions in the memory. Okay, understand here. So it means like maximum degree of multi-programming will be 8 only, right? And next, understand one more important point. Okay, the answer is not say, right? So this partition is having 50 KB size. This is having 100 KB size. This is having 150 KB. Okay, this is having 300, 200, so 250. So if you observe all the partition sizes here, what is the maximum size of the partition you are having? Maximum size कितना है बताओ? 300, right? So maximum size of the partition is only 300. It means okay, if any process comes, example process P1 is coming with the request of 350 KB. Okay, process P1 coming with the request of 350 KB. Now tell me, is it possible to accommodate here? No, not possible. You cannot accommodate this process here. That is not possible. So it means what? What's the next important point? Okay, maximum size of the process is restricted by maximum size of the partition. Maximum size of the process is restricted by what? Maximum size of the partition, because maximum size of the partition here is what? Only 300 KB. So if any process comes with a more than 300 KB size, it is not possible to accommodate. So maximum size is only what? Okay, 300 KB process can be accommodated here. Okay, note down next point. Next point लिखो. Maximum size of the process. Maximum size of the process is restricted by maximum size of the process is restricted by maximum size of the partition. Is restricted by maximum size of the partition. Okay, so fine. Okay, understand it. So that is the okay next point. Okay, now tell me next year. Okay, next one is process P2 here. Process P2 is coming with the request of okay example 30 KB size. Okay, the next process P2 is coming with the request of 30 KB size. Okay, now tell me, so when the P2 is coming with the request of 30 KB size, is it possible to accommodate here? Okay, yes. Okay, comfortably you can accommodate. So 30 KB process, okay, बहुत सारे खाली partition पड़ा हुआ है, किसी पे भी okay आप place कर सकते हैं, right? So understand here, so 30 KB process, let's say I am accommodating here. The answer सुनो जैसे इधर process P2 के लिए 30 KB चाहिए, तो you can comfortably accommodate. So if I accommodate in this here, okay, P2 if I am accommodate here, understand here, so this partition is having how much size? This partition is having how much size? 50 KB. This partition is having how much size? 50 KB. And this process requires how much size? Only 30 KB. So after placing the process P2 here, how much memory will be wasted here? How much memory will be wasted? Okay, tell me. 20 KB will be wasted. 20 KB memory will be wasted. Okay, right? So after placing the process P2 here, 20 KB will be wasted. Remember, this 20 KB wastage is called as okay internal fragmentation. Okay, this 20 kb wastage okay is called as a internal fragmentation. is that clear? Copy करो अच्छे से, ये दोनों भी कॉपी करो, ये दोनों कॉपी करो. सो P1 अगर आ रहा है 350 kb नॉट पॉसिबल टू अकोमोडेट. ओके, ये वाला P2 आ रहा है. ओके, यू कैन अकोमोडेट. सो P2 को यहाँ प्लेस करेंगे तो 20 kb वेस्ट होगा. सो दिस 20 kb इज कॉल्ड एज अ इंटरनल फ्रैगमेंटेशन. अच्छे से कॉपी करो. Okay, fine. So now understand here, so this 20 kb waste is called as a internal fragmentation. So why it is called as a internal fragmentation? Name ऐसा क्यों दिया गया? Because obviously that is internal to the process. Internal to the process, इसका मतलब process को place करने के बाद okay जो बच गया internally inside the partition. Is that clear? So that is a internal to the partition. So that's called as a internal fragmentation. Okay, so is that clear for everyone? Right. So that is about internal fragmentation. Okay, no doubt. Next point. Next point लिखो. Next point लिखो. Every partition. Next point. Every partition is associated. Every partition is associated with the limit registers. यहाँ पे लिख रहा हूँ. Every partition is associated with the limit registers. Every partition is associated with the limit registers. Okay, you will have the two limit registers. Okay, copy karo. One is okay lower limit. One is lower limit, and next is okay upper limit. So lower limit and upper limit. So understand here, lower limit contains starting address of the partition. Starting address of the partition. And upper limit contains ending address of the partition. Ending address of the partition. Okay, right. So copy this. Every partition is associated with the limit registers. Every partition is associated with the limit registers. Okay, one is a lower limit and upper limit. Okay, so lower limit contains what? Starting address of the partition, and upper limit contains what? Ending address of the partition. So just remember, इसको याद रखो. इसलिए हर एक partition का अपना अपना limit register रहेगा. So lower limit and upper limit. Okay, lower limit में क्या होगा? Starting address. वो partition का starting address होगा. Upper limit में ending address होगा. Okay. So that is about okay fixed partition scheme. Okay, that's all. So remember, if you observe all the points here. So in the fixed partition scheme, if you observe all the points, what are the major problems here? Major problems is restricted degree of multi-programming. That is the first major problem. And the second major problem is maximum size of the partition is restricted by maximum size of the process is restricted by maximum size of the partition. Is that clear? That is the second problem. Is that clear? So to avoid these two problems, okay, we'll go for the next type of partition scheme, that is variable partition scheme. Okay, to avoid this problem, we'll go for the next type of partition scheme. Okay, no doubt. Next one is variable partition scheme. So keep the heading variable partition scheme. So next one is the variable partition. Keep the heading variable partition scheme. So copy this diagram here. Okay, so copy this. We are having memory. Okay, copy this here. Okay, variable partition scheme. Okay, just copy this only. That's all. Okay, you are having memory like this. Okay, कुछ लोग partition बना दिए क्या? right? Okay, understand here. So no partitions here initially, right? So understand here. So first next move on to the variable partition scheme. In the variable partition scheme, initially memory will be, the answer is say initially memory will be single continuous free block. Okay, it is just like, okay, there is no partition here. Okay, it is just like a single continuous free block. Is that clear? And remember, whenever the request by the process arrives, कोई भी process का कोई request आता है, so then you make the partition. Okay, then you make the partition and accommodate the process. Is that clear? So don't worry, मैं notes देता हूँ, पहले सुनो. Okay, पहले first point लिखो. In the variable partition scheme, initially memory will be single continuous free block. Initially memory will be single continuous free block. Initially memory will be single continuous free block. Is that clear? Right. Okay. So that is a, okay. So variable partition scheme, initially memory will be single continuous free block. Note down. Next point. Whenever the request by the process, whenever the request by the process arrives, accordingly partition will be made in the memory. Okay, full stop. Now understand here. So whenever the request by the process arrives, okay, जब भी कोई process का request आता है, then what happens? Accordingly you make the partition. Okay, look at here. Let's say for example, okay, so now the P1, okay, is coming with the request of, okay, just listen here. So P1 coming with the request of 50 KB example. So P1 is coming with the request of 50 KB. So then what happens? Okay, you make the 50 KB partition. Okay, 50 KB partition बनाएंगे. And you will accommodate what? Process P1 को accommodate करोगे. Is that clear? So like this, whenever the request by the process comes, okay, arrives, accordingly you make the partition. Is that clear? So if this is the case, देखो यहाँ पे क्या है? Okay, you can make as many partitions you want. Okay, if the memory is freely available. So there is no restricted degree of multi-programming. There is no fixed number of partitions. Okay, जितना चाहिए, okay, उतना, okay, आप partitions बना सकते हो. प्रीवियस केस में क्या प्रॉब्लम था? ओके, डिग्री ऑफ मल्टी प्रोग्रामिंग इज रिस्ट्रिक्टेड बाय नंबर ऑफ पार्टीशंस. ओके, नाउ लुक एट, यहां पे देयर इज नो फिक्स्ड नंबर ऑफ पार्टीशंस, वेरिएबल पार्टीशन स्कीम. ओके, सो जितना पार्टीशन चाहिए उतना कर सकते हो आप. इज दैट क्लियर? एंड नेक्स्ट प्रॉब्लम क्या था? प्रीवियस केस में नेक्स्ट प्रॉब्लम क्या था? मैक्सिमम साइज ऑफ द प्रोसेस is restricted by maximum size of the partition. So यहाँ पे there is no restriction here. You can make as large partition as you want. Okay, if the memory is freely available. So okay, इतना बड़ा partition के एक process को accommodate कर सकते हैं. Is that clear? Now next, let's say for example P2 coming with the request of 400 KB. So process P2 coming with the request of 400 KB. So then what happens? You create a 400 KB partition here and accommodate the process P2 here. Okay. And next, okay, let's say P3, copy karo, P4, P5, P6 and P7 and P8. So let's say you are having the so many process coming here. Let's say next 350 KB. So example 200 KB, 250 KB, copy karo, 150 KB. So next 70 KB. Okay, so next is 300 KB. Okay, so copy karo, please copy this, P3, so P4, P5, P6, P7 and P8. Okay, so these are the requests coming. Okay, so accordingly you make the process partition here. So 350 का request आया, 350 KB partition बनाओगे. So next 200 KB का आया, 200 का बनाओगे. So next 250 KB. So look at here, so it's 150 KB. And next 70 KB and 300 KB. Okay, So whenever the request by the process arrives, okay, accordingly you make the partition. Okay, right. So this is okay how you make the partition whenever the request by the process comes. Copy करो अच्छे से पूरा, ये पूरा copy करो. अगर आप स्लो कॉपी कर रहे हैं तो पास करो, वीडियो पास करो. Okay, so हो गया सबका, right? So understand here. So that is a okay how you accommodate the process here. Okay. Now whenever the request by the process comes, accordingly you make the partition and accommodate the process. Okay. So the answers now say next. Let us say after some point of time. Listen carefully. The answer सुनना है. After some point of time, assume that process P1 is completed the execution and P7 also completed the execution. Let's say P1 and P7 are completed the execution. Complete कर चुका है. So then what happens? Okay, tell me. When P1 and P7 are completed the execution, obviously what happens? Memory will be what? Deallocated. Memory will be reallocated. The functionality of the memory manager. What is the functionality of the memory manager? Allocating and deallocating memory to the process. Allocating and deallocating memory to the process. So once obviously the process execution is completed, that will be removed from the memory, right? Memory से बाहर हटा जाएगा, right? बाहर हटा दिया जाएगा, right? So look at here. So this will be removed from the memory. So let's say okay, this will removed from the memory and removed from the memory. Okay, P1 and P7, right? So now tell me, once your P1 and P7 are removed from the memory, so this is removed. Let's say ये खाली हो गया. Okay. डोंट कॉपी, आप लोग कॉपी मत करो, कॉपी किया ना बस चेंज मत करो. ओके, जस्ट ऐसे रहने दो. सो नेक्स्ट ओके P7 P1 दोनों कंप्लीट कर चुका है. नाउ टेल मी हाउ मच मेमोरी इज फ्रीली अवेलेबल हियर. सो 50 KB मेमोरी फ्रीली अवेलेबल हियर एंड 70 KB मेमोरी फ्रीली अवेलेबल हियर. सो ओके मैं फिर से लिख रहा हूँ. लेट्स से P1 था कंप्लीट हो गया, सो P7 था कंप्लीट हो गया. ओके, सो यहाँ पे 50 KB पार्टीशन खाली है, यहाँ पे 70 KB पार्टीशन खाली है. सो टोटल हाउ मच मेमोरी इज फ्रीली अवेलेबल. So 50 KB partition here and freely available, 70 KB freely available here. Total how much memory freely available? 120 KB memory freely available. So 70 plus 50 कितना होता है? 70 plus 50 120, right? So total 120 KB memory is freely available. Remember, okay, let's say you are having 120 KB memory freely available. Even though you are having 120 KB memory freely available, if the process P9 is coming with the request of 100 KB, with the request of 100 KB, the answer is not just say now you are having total 120 KB memory is freely available. Even though you are having 120 KB memory freely available, if the P9 comes with the request of 100 KB, is that possible to accommodate? Is that possible to accommodate? Yes or no? No, right? So why? Because memory is not continuous. Memory is not continuous. मतलब यहाँ पे थोड़ा खाली है, यहाँ पे थोड़ा खाली है. Is that clear? So even though process comes okay with the 100 KB request, even though process comes with the 100 KB request, it is not possible to accommodate. Okay, because memory is not continuous. Memory is not continuous. So this problem is called as what? External fragmentation. Copy करो अभी अच्छे से. Okay, so this problem is called as external fragmentation. So this problem is called as external fragmentation. Copy करो, मैं साइड हो जा रहा हूँ. ये copy करो. ओके, सो P1 P7 कंप्लीट हो गया. ओके, ये भी लिखना है आपको. P1 P7 कंप्लीट हो गया, उसके बाद दोनों पार्टीशन खाली है. सो P9 इज कमिंग द रिक्वेस्ट ऑफ 100 KB. सो देन इट इज नॉट पॉसिबल टू अकोमोडेट. ओके, सो इवन दो 120 KB मेमोरी फ्रीली अवेलेबल, you cannot accommodate the process which is requesting only 100 KB. Why? Because the memory is not continuous. So this problem is called as what? External fragmentation. लिखो अच्छे से, लिखो पूरा. राइट, कॉपी किया, इसको कॉपी किए. राइट, सो दिस कॉल्ड एज व्हाट? एक्सटर्नल फ्रैगमेंटेशन. ओके, एक्सटर्नल फ्रैगमेंटेशन का डेफिनेशन बताओ. एक्सटर्नल डेफिनेशन क्या बोलना चाहिए? एक्सटर्नल फ्रैगमेंटेशन मींस even though memory is available, we are not able to make use of that. even though memory is available, okay, we are not able to make use of that because memory is not continuous. Okay, मतलब यहाँ पे थोड़ा खाली है, यहाँ पे थोड़ा खाली है, ऐसा कुछ है. Okay, so that's not a continuous. So that problem is called as what? External fragmentation. So next, okay, now let us say next point. Listen here. Now process P10 is coming with the request of 30 KB. Okay, think and tell me. Process P10 is coming with the request of 30 KB now. Is it possible to accommodate? Okay, yes, no problem. So you can accommodate. So process P10 comes with the request of 30 KB. You can comfortably accommodate. Okay, don't change the diagram. आप लोग change मत करो. Just listen here. So P10 requests 30 KB. Now tell me. So 50 KB partition is freely available here. 50 KB partition is freely available here. And 70 KB partition is the freely available here. 70 KB is freely available here. So you can accommodate the process P10 here, or you can also accommodate the process P10 here. So यहाँ पे accommodate कर सकते, यहाँ तो यहाँ पे भी accommodate कर सकते, क्योंकि दोनों free partition है. Now remember example, I am accommodating here. यहाँ पे accommodate कर रहा हूँ. Then सुनो जैसे. Now if I accommodate the P10 here, then what happens is this 50 KB partition. This 50 KB partition is divided into two parts. 50 KB partition is divided into two parts. Okay, one is the 30 KB and one is the 20 KB. One is the 30 KB and next is 20 KB. So क्योंकि उसको 30 KB चाहिए, so 30 KB का partition बनाओगे. So इसमें आप P10 को accommodate करोगे. इसमें आप P10 को accommodate करोगे. Okay, now tell me here, after placing the process P10 here, you are having 20 KB partition freely here. 20 KB partition is freely available. Now, can you call this 20 KB free partition? Can you call this 20 KB free partition as an internal fragmentation? Yes or no? No. Okay. So, you cannot call this as an internal fragmentation. Why? Because if any smaller process comes, you can still make use of that partition. Okay, if any smaller process comes, you can make use of that. So that is not called as internal fragmentation. Is that clear for everyone? Right. So understand here. What do you understand? क्या समझ में आया? If the smaller processes keep on coming, then the larger partitions will be made into smaller partitions. If the smaller process keep on coming, then the larger partitions will be made into smaller partitions. Okay, now don't change your diagram. आप लोग change मत करो, diagram change मत करो, पहले सुनो. Okay, now let's say यहाँ पे कोई छोटा process आया. Okay, हो सकता है यहाँ पे थोड़ा खाली memory free है, यहाँ पे थोड़ा खाली free है. Okay, you are having. Okay, if the smaller process keep on coming, then the larger partitions will be made into what? Smaller partitions. Okay, in that case, there may be possible that some free partition is available here. So some free partition available here. So यहाँ पे थोड़ा free partition है बीच में. Is that clear? So like this, in between you are having small free partitions. Okay, so in that case, now tell me, if any larger process comes, can you make use of this memory here? If any larger process comes, can you make use of this memory? No, not possible. Is that clear? Why? Because that is not continuous. So even though this much memory is freely available, you cannot make use of this. So all this is called as what? External fragmentation. Okay, आप लोग नया डायग्राम कॉपी करो, रफ डायग्राम कॉपी करो, पूरा वैल्यूज लिखने की जरूरत नहीं है. सो यहाँ पे ऐसा पार्टीशन बना के थोड़ा बीच में अगर खाली है, ऑल दिस इज कॉल्ड एज अ एक्सटर्नल फ्रैगमेंटेशन. पहले मेरा स्टेटमेंट लिखो, बाद में कॉपी करो. पहले एक स्टेटमेंट लिखो. इफ द स्मॉलर प्रोसेसेस कीप ऑन कमिंग, if the smaller processes keep on coming, then larger partitions will be made into smaller partitions. Larger partitions will be made into smaller partitions. Okay, full stop. Right. So then you can copy this. ओके कंप्लीट नया डायग्राम बनाओ, पूरा वैल्यूज मत लिखो, रफ डायग्राम कॉपी करो, ऐसा ऐसा ओके बीच में थोड़ा थोड़ा खाली रखो, राइट। सो ऑल दैट इज कॉल्ड एज अ एक्सटर्नल फ्रैगमेंटेशन। देखो यहाँ पे थोड़ा खाली है, यहाँ पे थोड़ा खाली है, यहाँ पे थोड़ा खाली है, कोई बड़ा प्रोसेस आया उसको यूज कर सकते हैं, नहीं कर सकते, व्हाई? बिकॉज दैट इज नॉट अ कंटिन्यूअस ओके मेमोरी, कंटिन्यूअस में नहीं है, ओके। सो इसलिए ऑल दैट इज कॉल्ड एज व्हाट? एक्सटर्नल फ्रैगमेंटेशन, ओके। रफ डायग्राम बनाओ, पूरा वैल्यूज लिखने की जरूरत नहीं है, जैसा रफ डायग्राम। ओके नाउ अंडरस्टैंड ये नेक्स्ट ओके कंटिन्यूएशन, राइट। ओके कॉपी नहीं किया तो ओके पास कर लो, पास कर लो। सो दिस कॉल्ड एज व्हाट? एक्सटर्नल फ्रैगमेंटेशन। रिमेंबर टू अवॉइड द प्रॉब्लम ऑफ एक्सटर्नल फ्रैगमेंटेशन, ये एक्सटर्नल फ्रैगमेंटेशन को अपना हटाने के लिए वी फॉलो सम टेक्निक्स, ओके। नोट डाउन कंटिन्यूएशन, कीप इट एज नोट टू avoid the problem of external fragmentation, the following techniques are used. Toward the problem of external fragmentation, the following techniques are used, okay. No doubt the first technique we follow is compaction. To avoid the problem of external fragmentation, we follow the following techniques, okay. Now the first one is what? Compaction, okay. No doubt keep the heading compaction. Now what is the meaning of compaction? Understand carefully. External fragment हटाने के लिए so we'll use technique called compaction. What's the meaning of compaction? Compaction means पहले सुनो अच्छे से, moving all the processes, listen here, moving all the processes towards the top, moving all the process towards the top or towards the bottom to make the free available memory in a single continuous place is called as what? Compaction. So moving all the processes towards the top or towards the bottom to make the free available memory in a single continuous place is called as what? Compaction. But remember, if you are moving all the process towards the top or towards the bottom, what happens? All the running processes in the memory will get interrupted. All the running process will in the memory will be get interrupted. So it means compaction idea may be good, but remember it is not suggestible to implement practically. Compaction is undesirable to implement practically. Compaction is undesirable, not suggestible to implement practically. Why? Because if you are implementing compaction, all the running processes in the memory will get disturbed or you say interrupted. Is that clear? Note down the definition. Compaction का definition लिखो पहले. Compaction definition: moving all the processes towards the top, moving all the processes towards the top or towards the bottom, moving all the processes towards the top or towards the bottom to make the free available memory, in a single continuous place, is called as compaction. To make the free available memory in a single continuous place is called as a compaction. Okay, full stop. Note down next point. Compaction is undesirable to implement. Compaction is undesirable to implement. Undesirable means what? Not suggestible. So undesirable to implement because it interrupts all the running processes, in the memory because it interrupts all the running processes in the memory. Is that clear? Right. So compaction, okay, idea may be good, but not suggestible to implement practically. So then what is other technique? Okay, फिर अभी ये external fragmentation कैसे हटाएंगे? How you are going to remove this? Okay, the next technique we follow is okay, note down, implementing non-contiguous memory management techniques. So the next technique we have is implementing non-contiguous memory management techniques. Okay, so it means okay, so ये external fragment हटाने के लिए the next technique we follow is implementing non-contiguous memory management techniques. Now tell me, what is the meaning of non-contiguous memory management techniques? Okay, like paging, multi-level paging, inverted paging, segmentation, and all that. Okay, so how we are going to implement paging and how you are going to avoid the problem of this external fragmentation, so that you will understand going forward. Is that clear? So पूरा आपको अच्छे से समझ में आना चाहिए. So first we started with what? Okay, contiguous memory management techniques में first क्या किया? Fixed partition scheme से start किया. In the fixed partition scheme you are having some problems, so to avoid that problems we are going for what? Okay, variable partition scheme. In the variable partition scheme also again you are having problem. Which problem? External fragmentation. So to avoid this external fragmentation, again the technique is what? Compaction. But compaction is not desirable. So that is the reason. Next we are going for what? Non-contiguous memory management techniques. That is the paging, multi-level paging and all that. So how we are going to implement paging and how we are going to avoid the problem of this external fragmentation, so that we are going to understand going forward. Is that clear? Right. So understand here. So before okay paging, okay, paging we will do that in the next session. So before we implement the paging, so we are having some okay small concept before okay paging. So that is the partition allocation methods. So first we will study that and later we will move on to paging. Okay, so before okay we discuss paging. Paging requires a lot of time, so maybe that we will do that in the next session. So we are having small topic. So first okay we will study this. So copy karo, partition allocation methods. Partition allocation methods. No doubt. So keep the heading partition allocation methods. What is the meaning of this? Okay, you will understand here. So partition allocation methods means okay, listen here. Heading लगाओ पहले. Right. So partition allocation methods okay means when more than one partition खाली है. Okay, for example कोई भी okay process को अपन accommodate करना है तो you need to decide which partition you are going to place. Okay, right. So अभी समझो ये partition यहाँ पे खाली है, यहाँ पे खाली है, यहाँ पे खाली है, तो कोई भी तो एक partition को decide करना पड़ेगा ना, right? So कैसे decide करोगे कौन सा partition में place करना है process को? So that will be decided by using what? Partition allocation methods. Okay, you will understand easily. So this is very easy. I think all of you studied this. First fit, best fit, worst fit. याद है थोड़ा थोड़ा, right? So no doubt. The first one is first fit. No doubt. So the first one is the first fit. Note down the definition. Keep the heading first fit. Note down. Allocate the process. Allocate the process in a partition. Allocate the process in a partition which is a first sufficient partition. Which is a first sufficient partition from top of the memory. First sufficient partition from top of the memory. Okay, understand here. So the answers know here. So first it means what? Okay, allocate the process in a partition. क्या लिखे थे? First sufficient partition from top of the memory. Is that clear? मतलब आप top से check करते आओ, top से check करते आओगे. Whichever is the first sufficient partition है, you place it there. Whichever is the first sufficient partition है, okay, you place in that partition. Is that clear? So that is called as a first fit. Okay. So no doubt. The next one is best fit. Next one is the best fit. Note down. Allocate the process. Note down. Allocate the process in a partition. Allocate the process in a partition which is allocate the process in a partition which is the smallest sufficient, which is the smallest sufficient among the free available partitions. Smallest sufficient among the free available partitions. Okay, understand here. So, smallest sufficient among the free available partitions. It means what? Whatever the free available partitions you are having. So, among all that, which one you select? Smallest sufficient. मतलब smallest होना चाहिए, sufficient होना चाहिए. Is that clear? So, you select that kind of partition. Is that clear? Right. Now, understand. Now, tell me, if you want to find out the smallest sufficient, then it requires to search all the free partitions in the memory. Right. सारे free partition को search करे तो ही आपको okay smallest sufficient मिलेगा. Right. Yes or no? Right. So, note down. Okay. Note down. Next point. To find out the smallest sufficient. To find out the smallest sufficient. It requires to search. It requires to search all the free partitions in the memory. To find out the smallest sufficient, it requires to search all the free partitions in the memory. Okay. So, सारे free partitions search करे तो ही smallest sufficient मिलेगा अपने को, बस इतना ही है. Right. So, next note down. The next one is the worst fit. Note down. The next one is the worst fit. What is the meaning of worst fit? Note down. Allocate the process. Allocate the process in a partition. Allocate the process in a partition which is largest sufficient. Which is the largest sufficient among the free available partitions. Which is the largest sufficient among the free available partitions. Okay. Now, understand carefully. Largest sufficient बोल रहा है. Okay. This is exactly same. Opposite to what? Best fit. Exactly opposite to best fit. Okay. So, best fit में क्या बोला था? Smallest sufficient. यहाँ पे क्या बोल रहा है? Largest sufficient. Is that clear? Now, same thing here also. To find out the largest sufficient, it also requires to search all the free partitions in the memory. So, all the free partitions we search, then only you can understand, okay, what is the largest sufficient, right? Note down. Next point, to find out largest sufficient, to find out largest sufficient, it requires to search, all the free partitions in the memory. It requires search all the free partitions in the memory. Okay, same thing. Okay, that is a worst fit. So, next, note down the next one. Next one is next fit. Note down next fit. Okay, so what is the meaning of next fit? Okay, note down. The next fit also works like the next fit also works like a first fit. The next fit also works like first fit, but it will search for the first sufficient partition. It will search for the first sufficient partition from यहाँ पे लिख रहा हूँ, इधर देखो, from last allocation point. Last allocation point, LAST, not LOST. Okay, last allocation point. It will search for the first sufficient partition from last allocation point. Okay. See, understand here, next fit also works like what? First fit only ओनली डिफरेंस क्या है, इट विल सर्च फॉर द फर्स्ट सफिशिएंट पार्टीशन फ्रॉम लास्ट एलोकेशन पॉइंट। मतलब क्या होता है, लास्ट टाइम मेमोरी रिक्वेस्ट कहां पे सेटिस्फाई हुआ था, लास्ट टाइम मेमोरी रिक्वेस्ट कहां पे सेटिस्फाई हुआ था, वहां से सर्च करेगा। समझ में आया सबको, राइट? बस इतना ही है, लास्ट टाइम मेमोरी रिक्वेस्ट कहां पे सेटिस्फाई होता है वहां से सर्च करेगा। सो फर्स्ट फिट, व्हाट द फर्स्ट फिट विल डू, फर्स्ट फिट विल ऑलवेज सर्च फ्रॉम व्हाट, टॉप ऑफ द मेमोरी ओनली, टॉप ऑफ द मेमोरी, बट द नेक्स्ट फिट विल सर्च फॉर द ओके फ्रॉम द लास्ट एलोकेशन पॉइंट। मतलब लास्ट टाइम मेमोरी रिक्वेस्ट कहां पे सेटिस्फाई हुआ था, राइट? सो डोंट वरी, सो ऑल विल बी क्लैरिफाइड, everything will be clarified by solving the questions, okay, right? Obviously, note down the question first, note down the question, consider, question लिखो, consider the following memory map, consider the following memory map, ओके अच्छे से कॉपी करो, डायग्राम इज लेंदी। क्रॉस हो गया क्या? ओके so please copy this, so copy this, this 8 KB, so 12 KB, 22, 18 KB, so 8 KB, 14 KB, 36 KB, so this is a 14 KB and 36 KB, okay? So this is what a free partition, so this is a free here, this dotted one is what a busy partition, okay? So this is given to you, and he is saying that this is the last allocation point, okay, this one last allocation point. So I think my font size is visible, okay? कॉपी करो, अच्छे से कॉपी करो। Okay, so understand here. Next, I think all of you copied. So if you are not copied, then pause my video. Okay, that's it. So okay, pause karo, continue mat karna, right? Okay, understand here. Next, okay, let's say some process P1. The answer is say process P1 is coming with the request of 16 KB. Just say example. Okay, now understand here. So process P1 with the process P1 is coming with the request of 16 KB. Now tell me, by using the various partition allocation methods, okay, इसको use करके, okay, in which partition you are going to accommodate, okay, that's what you have to tell me, right? So ये diagram जो copy किया, diagram के बाजू में ये चार लिखो, ये नाम लिखो, first fit, best fit, worst fit, next fit लिखो, diagram के बाजू में लिखो या तो नीचे लिखो। क्या बाजू में गलत है क्या? बाजू में, बगल में, सही तो है, राइट. ओके, अंडरस्टैंड हियर. ओके, सो जस्ट राइट. ओके, इसका बाजू में लिखो या तो साइड में लिखो, राइट, वॉट एवर. सो okay, so understand here. So P1 is requesting for 16 KB memory. So now you have to tell me by using various partition allocation methods in which partition you are going to accommodate. Is that clear? So now tell me, if I use the first fit, बताओ आप लोग. Okay, listen here. So this one is a blank one is what? A free partition, and this is dotted one is what? A busy partition. You can understand easily. So now tell me, if I use the first fit, in which partition you will accommodate? First fit का definition क्या है? First sufficient partition from top of the memory. First sufficient partition from top of the memory. So you keep on searching here. 16 KB चाहिए P1 को. Is it sufficient here? No. Is it sufficient here? No. Is it sufficient here? Yes. Okay. So you are going to accommodate in the 22 KB partition. Okay. 22 KB partition में place करोगे. Is that clear? So okay, if the P1 is coming, by using first fit you accommodate in the 22 KB partition. Now tell me, if I use the best fit, बताओ अगर मैं best fit use करता हूं तो कौन सा partition place करोगे? Best fit means what? Smallest sufficient partition. Smallest होना चाहिए, sufficient होना चाहिए. Now tell me, okay, these are smallest sufficient. 16 KB के लिए sufficient कौन है? ये वाला sufficient है, ये वाला sufficient है, ये वाला sufficient है. So among all this, smallest and sufficient, which one is that? 18 KB. So you accommodate in the 18 KB partition. Okay, you accommodate here. Okay, so if I use the best fit, and next now tell me, if I use the worst fit, if I use worst fit, where you accommodate? Worst fit, largest sufficient. Worst fit मतलब क्या होता है? Largest sufficient. Now tell me, among all this, which one is the largest and sufficient? That is the 36 KB. So if I use a worst fit, you place in the 36 KB partition, right? Now tell me, if I use the next fit, where you are going to accommodate? Okay, if I use the next fit का definition क्या बताया? Next fit also works like a first fit. Next fit also works like first fit, but you'll search for the first sufficient partition from last allocation point. So now tell me, last allocation point, यहाँ से search करेगा. Is it sufficient? No. Is it sufficient? No. Is it sufficient? No. Is it sufficient? Yes. Okay, so you are going to place in the 36 KB partition. Okay, so now look at here. So this is the 36 KB partition. So you accommodate like this. Is that clear for everyone? So this is the meaning of all this. Okay, right. Note down the next question. Note down the next question. Okay, for the same diagram, note down the next question. How many successive requests of six KB will be satisfied by using first fit, assuming variable partition scheme. Assuming variable partition scheme. Okay, question is clear. Okay, copy करो question पहले अच्छे से. How many? Okay, ये पूरा खाली है, सेम डायग्राम. ओके, रिमेंबर P1 को हम अकोमोडेट नहीं किया, जैसे सेम डायग्राम बोला मैं, सेम डायग्राम. हाउ मेनी सक्सेसिव रिक्वेस्ट ऑफ 6 KB will be satisfied by using first fit, assuming variable partition scheme. Okay, so think carefully and answer. So solve करो, right? So we are still solving. Okay, you can simply pass करो. अगर आप solve कर रहे हैं तो pass करो अच्छे से, solution नहीं देखना, right? So what is the right answer? Okay, right answer is 19. 19 is the right answer. 19 successive requests of 6 KB can be satisfied. Okay, now tell me how many successive 6 KB यहाँ पे बताओ. Okay, इसमें कितना 6 KB लगा सकते हैं? Okay, डाल सकते हैं 1. Okay, in this 12 KB है, how many 6 KB you can place? 2. Okay, in this 22 KB है, how many 6 KB you can place? 22 में कितना? 3. यस और नो, ओके 6 times 3 is 18, राइट. सो इसमें 3 लगा सकते हैं. सो इसमें कितना 6 KB, ओके 3, ओके इसमें 1, ओके इसमें 1, इसमें 2, ओके इसमें 36 है, इसमें कितने 6, ओके ऐड करो टोटल. सो 6 8 9 10, ओके 10 है, ओके सो 3 3 3, ओके सो 19, करेक्ट. So 19 successive requests of 6 KB can be satisfied. Okay, is it clear for everyone? Yes or no? Okay, right. Okay, I am assuming yes. Obviously that is yes only, right? Okay, fine. Okay, we'll take up one more question. Okay, so the next question is interesting. Okay. ओके, नोट डाउन द नेक्स्ट क्वेश्चन. क्वेश्चन लिखो पहले. कंसीडर द फॉलोइंग मेमोरी मैप. क्वेश्चन लिखो. कंसीडर द फॉलोइंग मेमोरी मैप. ओके, कॉपी करो अच्छे से. Okay, so this is a 150 KB and this is a 350 KB. Okay, so partition numbers, this is 0 1 2, okay 3, okay that's order. Okay, simple. Okay, note down. Question is the request from the processes are 300 KB, 25 KB, 125 KB, 50 KB respectively. Okay, the requests from the processes are what? 300 KB, 25 KB, 125 KB, 50 KB respectively. Okay, full stop. Okay, next, the above requests could be satisfied with, okay the above requests could be satisfied with. ओके, सो ब्रेसिस में दिया है अज्यूम वेरिएबल पार्टीशन स्कीम. Okay, so options are given to you. Options: best fit but not first fit. Option B, first fit but not best fit. Option C, both first and best fit. Option D, neither first nor best fit. So think carefully and solve. So this is a good question. जल्दी जल्दी करके गलत मत बोलो. ओके, दैट इज इंपॉर्टेंट है. ओके, सही आंसर लाना इंपॉर्टेंट है. जल्दी जल्दी करके गलत मत बोलो. ओके, मैं साइड हो जा रहा हूं. ओके अगर आप सॉल्व कर रहे हैं, इफ यू आर स्टिल सॉल्विंग, पास करो, वीडियो पास करो, अच्छा क्वेश्चन है, डोंट कंटिन्यू द वीडियो। आप सॉल्व करने के बाद ही वीडियो कंटिन्यू करो। ओके हो गया सबका, राइट। So, okay, if you are solving, okay, if you are already solved, so let's try to understand. If you are already solved, so let's see what is the right answer. हो गया सबका? I am revealing the answer. So, right answer is, okay, B. Okay, B is the right answer. First fit, but not the best fit. Okay. Now, I don't understand. Many people are giving wrong answers. Okay, कुछ लोग ये बोल रहा है, कुछ लोग C बोल रहा है. Okay, I don't understand. So, let's go with the best fit. Best fit से try करो, हो रहा है नहीं हो रहा है best fit. अब बताओ, first 300 kV. अगर आप बेस्ट फिट फॉलो कर रहे हैं, ओके, बेस्ट फिट फॉलो कर रहे हैं, तो बताओ कहां पे होगा? 300 के भी यहां पे तो नहीं होगा, ऑब्वियसली यहां पे, ओके, राइट, ओके, बेस्ट फिट का कर रहा हूं। अगर यहां पे प्लेस कर रहा है तो 300 के भी करेंगे, तो यहां पे यू मेक द पार्टीशन हियर एंड हाउ मच विल बी फ्री हियर एंड 50 के बी विल बी फ्री हियर। समझ में है? ओके, अगर बेस्ट फिट फॉलो करते हैं तो 300 के भी यहां प्लेस करेंगे तो 50 के भी फ्री है। एंड नेक्स्ट 25 के भी आया तो क्या करोगे? तो ऑब्वियसली यहां पे स्मॉलेस्ट सफिशिएंट, बेस्ट फिट मतलब यहां प्लेस करेंगे, तो यहां प्लेस करेंगे तो कितना बचेगा बताओ? यहां पे 25 के भी बचेगा, 25 के भी बचेगा। एंड नेक्स्ट ये दोनों हो गया। उसके बाद 125 के भी है, तो कहां प्लेस करोगे? देखो यहां प्लेस करोगे, यहां पे प्लेस करेंगे तो 125 के भी, तो कितना पार्टीशन यहां पे बचेगा? 25 के बी का बचेगा, इजली है। एंड द लास्ट वन इज व्हाट? 50 के बी। नाउ टेल मी, इज इट पॉसिबल टू अकोमोडेट 50 के बी? 50 के बी यहां पे प्लेस कर सकते हैं क्या? अभी नहीं कर सकते। वाई? बिकॉज 25 के बी यहां पे खाली है और 25 के बी यहां पे खाली है, इजली है। सो ओके, मेमोरी इज नॉट कंटिन्यूअस, so you cannot accommodate okay 50 kb process, then you cannot accommodate the 50 kb process. So is that clear for everyone? Right, so it is not possible with the best fit. Okay, best fit से possible नहीं होगा। नेक्स्ट ओके, लेट्स ट्राई विद द फर्स्ट फिट। ओके, डाउट है तो सुनो इधर। सो फर्स्ट फिट से ट्राई करो अभी। ओके, फर्स्ट फिट से करेंगे तो क्या होगा बताओ? फर्स्ट फिट अगर यूज कर रहा है 300 kb फर्स्ट फिट, ओके, इज इट सफिशिएंट या नो? इज इट सफिशिएंट या यस? सो 300 kb है तो यहां प्लेस करोगे, यहां प्लेस करेंगे तो कितना बचेगा? 50 kb बचेगा, 50 kb बचेगा, ये वाला हो गया। नेक्स्ट 25 kb के लिए फर्स्ट फिट डेफिनेशन क्या है? फर्स्ट सफिशिएंट पार्टीशन। ओके, लुक एट हियर, सो इज सफिशिएंट या यस? सो फर्स्ट सफिशिएंट है तो यहां पे प्लेस करेंगे। बताओ यहां पे 25 kb प्लेस करेंगे तो यहां पे कितना बचेगा? 125 kb बचेगा। ओके, ये वाला पार्टीशन बचेगा, राइट। सो नेक्स्ट उसके बाद ओके 125 kb है, कैन यू अकोमोडेट हियर? यस, 125 kb है तो यहां पे डाल दो। ओके, यहां पे प्लेस करो। नेक्स्ट लास्ट में क्या है बताओ? 50 kb, कैन यू अकोमोडेट? यस, 50 kb के लिए ये पार्टीशन खाली है तो यहां पे प्लेस करो, राइट। सो इट इज पॉसिबल विद द फर्स्ट फिट बट नॉट विद द बेस्ट फिट। It is possible with the first fit but not with the best fit. Okay, so right answer is a B. B is the right answer. So जल्दी करके गलत आंसर नहीं बोलना चाहिए। So questions like this are very important. Okay, easy. अभी देखो ये क्वेश्चन क्या है? Okay, उतना टफ भी नहीं है, उतना इजी भी नहीं है, मॉडरेट क्वेश्चन। So if you do mistake in these kind of questions, directly you go 500 ranks down. Okay, मैं ऑलरेडी बताया प्रीवियस सेशन में, इजी क्वेश्चंस एंड मॉडरेट क्वेश्चंस पक्का करना है, सही करना है, इजली है। उसके बाद जितना टफ क्वेश्चन करोगे उतना रैंक ऊपर जाएगा, राइट। सी इस एग्जाम्पल, ओके, ऑलरेडी सुनो, गेट एग्जाम में सिंपल ट्रिक समझो। गेट एग्जाम का ट्रिक क्या है? इजी क्वेश्चंस, मॉडरेट क्वेश्चंस का ही ट्रिक है। ओके, फॉर एग्जाम्पल समझो अगर बहुत टफ क्वेश्चन आया, सिंक्रोनाइजेशन से एक बहुत खतरनाक टफ क्वेश्चन आया, ओके, ज्यादा लोग नहीं करेंगे, टेंशन लेने की जरूरत नहीं है, बहुत कम लोग करेंगे, करे तो अच्छा है, नो प्रॉब्लम। लाइक फॉर एग्जाम्पल तुमने क्या किया, इधर सुनो अच्छे से, मैं जो बोल रहा हूं सुनो अच्छे से। सिंक्रोनाइजेशन से एक अच्छा क्वेश्चन आया, टफ क्वेश्चन आया, समझो तुमने बहुत अच्छा टाइम लेके उसको, तुमको अच्छा लगा, बहुत मजा आया क्वेश्चन सॉल्व करने में, बहुत अच्छा टाइम लेके वो क्वेश्चन को तुमने सॉल्व किया। ओके, तुमने सॉल्व किया, ओके, वेरी गुड, ओके, अच्छा फील हुआ तुमको, अच्छा सॉल्व किया। मगर ऐसे ही कोई छोटा मोटा क्वेश्चन आया, ओके, इसको गड़बड़ करते हुए इसको क्या किया तुमने? गलत किया। इसको गलत किया। ओके, सुनो अच्छे से क्या बोल रहा हूं। अभी दूसरा बच्चा क्या करेगा, दूसरा बच्चा क्या करेगा, सिंक्रोनेशन का क्वेश्चन देखते ही अरे ये मेरे से नहीं होगा, टफ क्वेश्चन है बोल के उसको छोड़ देगा, उसको छोड़ देगा। मगर ये इजी क्वेश्चन ऐसा जो है इसको क्या करेगा, पक्का सही करेगा, सही करेगा। अब बताओ ये इस दोनों में कौन सुपीरियर है, दोनों में कौन सुपीरियर है, दूसरा बच्चा सुपीरियर है। जो सिंक्रोनेशन का किया वो सुपीरियर नहीं है, जो इजी क्वेश्चन किया वो सुपीरियर है। वाई, बिकॉज दूसरा बच्चा जो क्या है वो क्या किया, सिंक्रोनेशन का क्वेश्चन का सिंपली छोड़ दिया और इसको अच्छे से सॉल्व किया, उसको 2/2 मार्क्स आ गया। ओके, 2 मार्क का क्वेश्चन है, 2 मार्क्स आ गया। अब सिंक्रोनेशन क्वेश्चन को क्या हुआ, उसका सिंक्रोनेशन का सही हुआ, ये वाला गलत हुआ, तो इसका नेगेटिव मार्क्स ऐड होगा, नेगेटिव मार्क्स ऐड होगा। समझ में आ रहा है सबको अच्छे से, राइट। सो ओके, हाउ यू अटेम्प्ट द क्वेश्चन पेपर, दैट इज ऑल्सो इंपॉर्टेंट। क्वेश्चन पेपर को आप कैसे अटेम्प्ट करते हैं वो इंपॉर्टेंट है, इजली है। ओके, राइट। सो सेम थिंग, इजी एंड मॉडरेट क्वेश्चन पक्का करना है, सही करना है, इजली है। समझो तुमने टफ क्वेश्चन किया और इजी क्वेश्चन छोड़ दिया, कोई मतलब नहीं है। दूसरा बच्चा क्या करेगा, टफ क्वेश्चन छोड़ देगा, इजी क्वेश्चन करेगा। समझ में आया सबको, राइट। दोनों इक्वल हो जाओगे, right? So okay, so be careful, okay, right? Be careful when you are attempting the question, okay? So come back to this question, okay, this question, okay, इधर सुनो अच्छे से। यहाँ पे क्या हो रहा है, first fit is satisfying the request, so first fit is satisfying the request but not best fit। फर्स्ट फिट सेटिस्फाई कर रहे हैं, ओके, बट नॉट सफिशिएंट। सो जनरली अपन क्या सोचते, जनरली अपना मन में, जनरली एज ए कॉमन यूजर और एज ए कॉमन ह्यूमन बीइंग यू फील दैट बेस्ट फिट विल ऑलवेज वर्क करेक्ट। थोड़ा ऐसा लगता है ना अपने को, राइट? क्योंकि बेस्ट फिट का डेफिनेशन ही बोलता है कि छोटा वाला में प्लेस करो, पहले छोटा वाला में प्लेस करो, राइट? सो ओके, इट मीन्स एज ए जनरल यूजर, ओके, जनरली यू मे फील दैट बेस्ट फिट विल ऑलवेज गिव यू द बेस्ट रिजल्ट, बट दैट इज एब्सोल्युटली रॉन्ग। It all depends on free available partitions and also the request of the processes. It all depends on free available partitions and also the request of the processes. So this is the example where the first fit is satisfying the request but not best fit. Is that clear? So okay, you need to be careful when you are answering the questions, right? So okay, so that is about partition allocation methods. So this is simple and easy, okay? So in the next session we will move on to the important topic, that will be paging, okay? So what is the meaning of paging and why we are going for paging and how we are going to implement paging and what you are going to achieve in the paging. So all that you will going to understand in the next sessions, okay? So thank you so much. So keep smiling and keep learning and try to solve the workbook. Thank you.